Okay, so this lesson is a quick introduction to the spheres of the Earth, a recap on the processes that formed the Earth and the solar system, and a very quick introduction to the structure of the Earth. So, first of all, the spheres of the Earth. You might have heard of the atmosphere, which is all the gases that sit basically over the surface of the Earth. It extends from ground level where we are, the air that we breathe, right up to the point at which there's a boundary between the atmosphere and empty space. So you would, I hope, understand that the atmosphere thins out as you go higher into it, which is why people at the top of mountains, Mount Everest, for example, really have trouble breathing. Um, and it is much denser down close to the surface of Earth where we are. Okay, so the atmosphere is gases like oxygen, water vapor. It's the bulk of it is made up of nitrogen. 80% of it is nitrogen. About 20% of it is oxygen, and everything else is trace gases like carbon dioxide and methane. Now, the hydrosphere is also pretty straightforward to understand. The hydrosphere is just the term that we use to refer to any bodies of water or any of the water on Earth. And you would know that water cycles around the Earth through the oceans, through rivers, up into clouds, back down as rain. Um, all of those aspects of the water cycle are the hydrosphere. They're part of the hydrosphere. So there's a little bit of crossover between the hydrosphere and the atmosphere because you can consider the water vapor in the air to be part of both. Um, and there are blurry lines between all of these spheres, but hydro means water, so that's what we're talking about whenever we mention the hydrosphere. Now, the biosphere is pretty straightforward too. All these little green sections here on this picture of Earth would be part of the biosphere. It's any living thing. Bio means living. Biology is the study of living things. So the biosphere includes you and me. It includes all the fishes in the seas, birds, bacteria, plants, fungi, uh, everything that you would define as living, you would define as part of the biosphere. Um, Obviously, there are things that sit on the boundary. We are not always sure whether to define viruses as living or non living, but usually, when we're talking about the earth, it's pretty straightforward the difference between living and non living things. Now, the final sphere that we talk about, you'll sometimes hear referred to as the lithosphere, you'll sometimes hear it referred to as the geosphere. In year 9, those terms are used pretty interchangeably. They mean basically the same thing. Technically, when you get to year 11 and you do earth science, the geosphere actually refers to all the layers of the earth down to the core, and the lithosphere just refers to everything up in the crust and the solid part that is stuck to the bottom of the crust of the earth. But in year 9, it's better to refer to it as the lithosphere, but it's fine if you refer to it as the geosphere as well. So the lithosphere is all the rocks and landforms on Earth, including the Earth's crust that runs underneath the oceans, and it includes all the landforms, mountains, volcanoes, anything that is rocky or anything that contributes to rocks. So sand and sediments are considered part of the lithosphere as well. So those are the 4 spheres. Now, what we want to talk about, or what you have talked about recently, and I just want to recap with you, is how all that stuff came to be. So, the first thing that happened around about 5 billion years ago was we had somewhere in our neighborhood, the neighborhood of our solar system, there was some kind of supernova. And that created a whole heap of dust and gas was sort of expelled during that supernova explosion of a a dying star, and a bunch of that started to kind of swirl into a bit of a whirlpool, and the center of that, due to the force of gravity, became really, really dense. Gravity attracts objects to each other, so the dust was attracted to other bits of dust, and that tended to happen in the center of this whirlpool. So it eventually became dense enough and pressures became great enough in this area that nuclear fusion started to happen. And that's the beginning of the formation of the sun. Once that sun, our star, had formed, all the surrounding gases started to kind of get pulled into its orbit and kept swirling around in this disk. At some point, the blasts of solar wind, which is radiation from the sun, pushed all the gases out into the outer part of that disk, and that meant that the inner part kept all the denser materials, the more rocky materials, and the outer part had the gases and more volatile substances. So that's why today we've got, out in the outer reaches of our solar system, we've got the gas giants, and in the inner part of the solar system, we've got the rocky planets like Earth. So we've got all this spinning dust and gas going around and around, and gravity starts to clump all the bits of dust that are spinning around together, and they gradually get bigger and bigger until they start to form boulders. Now, the bigger they get, the more attractive they become to other bits of dust, because gravity, one of the factors that affects gravity is the mass of the objects involved. So as an object grows in mass, its gravitational pull is going to increase and it's going to attract more and more dust to it. So, eventually those boulders are going to start to get bigger and bigger, and they're going to start to have a bit of a fight within their orbit. They're going to start smashing into any other object that is in their orbit, and as they smash, they're going to smash together and form bigger and bigger objects still. So that's kind of why all the planets are spaced out the way they are in their orbit around the sun, because if they were on the same orbit, eventually they would just smash into each other and either sort of blast fragments out away into the rest of the solar system, or smash and form one big object and stay in orbit as a larger object. The most significant of those collisions for Earth was when another protoplanet, which is potential forming planet on the same orbit as Earth, smashed into Earth just around about the time that it was being formed. That massive planet was called, or protoplanet was called Theia, and a big chunk of it broke off and formed our moon. And that moon orbiting around Earth actually stabilized the rotation of Earth nicely, which has kind of settled the planet down enough that it's become much more inhabitable because of the presence of that moon. Okay, so eventually we ended up with all the planets in the orbits that they're in at the moment. And this is just a summary of that. We've got the supernova, the beginning of that spinning disk, the process continuing, dust and gas forming into protoplanets, and then eventually we've got the planets there. This process of boulders being added to and things clumping together due to gravity is referred to as accretion, A-C-C-R-E-T-I-O-N. So that is how our solar system formed. Now, Earth itself, in its molten state, underwent this process whereby the heavier, denser elements sank towards the center of gravity of the Earth, and the lighter ones stayed around the outside. And that is the reason that today we've got these layers in the Earth where there's a solid, very dense inner core, because the dense iron and nickel sank down back when the planet was molten, And the lighter elements like oxygen, silicon, aluminium all stayed up near the surface. They didn't sink down just because of those different densities. So this structure is the thing that you're going to be looking at next, and you'll be looking at that in more detail during this lesson.